Back. In this video, we are going to be proving that for all xyz in R, x squared plus y squared plus z squared is greater than or equal to xy, yz, and zx. Xy plus yz plus zx. In order for us to prove this, we need to use properties of real numbers. So, generally, let's start by saying let x, y, z be real numbers, right? So you can actually see that we have x squared, y squared, and z squared, which means we need a square of something, but also we have xy, yz, and zx. So it means that we need combination of x and y and z and x. How do we do that? We now have to consider the properties of real numbers. X, we need the combination of x and y. So x minus y squared, we know that it's greater than or equal to 0. The squared is coming from the fact that I can actually see that I have squares here, and the x minus y is the one which will make a combination of x and y. That is why I used this. And the property x minus y is greater than or equal to 0 is just a property of real numbers. Then the other one is we want y and z. So y minus z squared is greater than or equal to 0. And the last one is z minus x squared is greater than or equal to 0. Then what happens if we add this, that, and that? We still retain something which is greater than or equal to 0. So we're going to say x minus y squared plus y minus z squared plus z minus x squared are all greater than or equal to 0, because we're just adding positive numbers there, so they always give us a positive number. So what does that mean? It means that x squared minus 2xy, we're now expanding, plus y squared plus y squared minus 2yz plus z squared plus z squared minus 2zx plus x squared, they are all greater than or equal to 0. They're all greater than or equal to 0. And what does this mean? It means that if we could add what can be added this side, we can actually see it here. We have got x squared and x squared. Where is the other x squared? There it is. X squared and x squared. And we also have got y squared and y squared, and we also have got z squared and z squared. So it means that we are forming 2x squared plus 2y squared plus 2z squared. These are all okay. We have still minus y z minus 2xy minus 2zx. They are all greater than or equal to 0. Then we take these ones. We take these ones to the other side. What do we get? We get 2x squared plus 2. We can just factor out 2 there so that we avoid writing 2. 2 by x squared plus y squared plus z squared is greater than or equal to 2yz by xy zx. And if we divide by 2 both sides, we just get x squared plus y squared plus z squared is greater than or equal to yz plus xy plus zx, and which is exactly what we wanted to prove. So the proof is complete.